My name is Brad Swanson. Like Doug, I work for Energy Solutions. Like Chuck Munns, I spent 20 years in the nuclear Navy on submarines and various other things. The last 10 years I've been working in the DOE complex, and right now I'm the salt waste processing facility plant manager. It's a new facility we're building out on Savannah River site, and the agenda that says SWPT, it's actually SWPF, but I was thinking maybe changing it to salt waste processing team, so that actually had a good ring to it. This presentation is about power generation fundamentals, and because I can't do two things at once, Bill's going to click through the slides for me. Go ahead, next slide. What we're going to talk about is a basic understanding of energy production processes, and this is going to be a fairly high-level discussion of the various sources of energy. We're going to talk about how much energy we use in the world in the United States, what the meaning of base, intermediate, and peak load are. That's an important concept for now and future energy needs. Where does our energy come from? Who uses it? What are the projections for the future? And a little bit about will we have enough to supply the world's energy needs in the future for our grandkids and our great-grandkids? Go ahead, next slide. Okay. So electrical energy, if we're trying to get electricity to heat our homes and to light our lights, the basic concept is we need to turn a generator that produces electricity. And the prime mover that turns that generator could be supplied by a number of different sources. It could be a coal plant, it could be a nuclear plant, it could be a gas turbine plant. There's a lot of different things. So we're going to talk about the whole cycle. Go ahead, next slide. Now, essentially, to produce that electrical energy at the end, you have to start with a fuel source. Okay, so we have some sort of fuel, whether that be coal, whether that be natural gas, whatever it is. Next. And for fossil fuels, we're going to do something to chemically alter that fuel. Okay, next. And in a boiler, you're going to heat, go ahead, next one. You're going to heat water that's going to produce steam. That steam is going to turn a turbine, and that turbine is going to turn a generator. And that generator is going to produce electricity to supply our homes, residential, whatever needs there are. Okay, next slide. So talking about generating electricity, a little bit about a generator. A generator is basically a device that converts mechanical energy, a rotational mechanical energy, into electrical energy. And it uses a basic principle that if you move a conductor, an electrical conductor, through a magnetic field, you'll induce electron flow in that conductor. And a prime mover that rotates the generator, again, can be driven by many different sources. Go ahead, next one. So the generator principles of operation. We need some sort of prime mover, and we'll get that in a second. Go ahead. That's going to rotate a conductor in a magnetic field. Now, the magnetic field can rotate or the conductor can rotate. It doesn't really matter. But once you do that, go ahead, next slide. Electricity flow will be induced in this conductor. And I'm not going to get real deep into that because that's not the main purpose of this lecture. But take my word for it, that concept works. Motion, flux, and current, as Bill is pointing out. All right, next slide. So as far as this plant generating electricity, and then you have some sort of distribution system that gets the electricity to where it's needed. And one of the things you'll see is that we step up the voltage significantly to distribute it long distances. Does anybody know why that's done? You go to 13,800 volts when you plug something into the wall. What's the voltage coming out of here? 110, right? 110 volts. So, but the voltage that you have going down the wires is much, much, much higher. And the reason for that is because it's much more efficient to do that. You have a lot less losses. Because you can think of current that's flowing through a wire similar to water flowing through a piping system. And if you up the voltage, you reduce the amount of resistance of that current flowing down the wires. But then you need to step it back down to get to your house. So that's the basic distribution system. Okay, next slide. A lot of our generation comes from fossil fuels. In fact, over 70% of the United States electricity needs come from some sort of fossil fuel. And a fossil fuel is something that coal, natural gas, petroleum also supplies about 98% of our transportation needs. I mean, how many people own an electric car? Does anybody own? Does anybody own a hybrid? At least you get part. Well, you got a little bit of it. So even in this room, if we took that 98% number, we're probably right. We're all fossil fuel kind of people. Okay, next slide. And fossil fuels, as you probably know, they come from over millions of years, some sort of organic material that under pressure and heat forms coal or oil and natural gas. Go ahead, next slide. Okay, so let's talk a little bit about coal. Next slide. Can you go back one? Back one. Back one. Back one. Let's go back to the electrical generation activity. Again, we have multiple different power sources, and here's where I need 3 volunteers. Can I have 3 people come up here? Say, one from, there we go. Oh, we got 3 people. Okay, I'm going to assign you as Nuclear Power Plant Vogel in Waynesboro, Georgia. And this is your power plant. And the way we're going to operate these things, looking at it, you're going to turn in a clockwise direction. Okay? And you're going to be a hydroelectric plant, a Hoover Dam. And you're going to be a coal plant. That's the plant Yates in Newman, Georgia. Does anybody know about plant Yates? I'm not real familiar with this area. I'm originally from Wisconsin and lived in Idaho for a lot of years. So we're, hang on a sec. All right, now what we have here is our simulated cities. So we have, and forgive me, I'm a Navy guy, Alpha, Bravo, Charlie, Delta, and Echo cities that we're going to supply. Okay, so now we're going to try, all 3 of you, go ahead and start cranking in the clockwise direction. You see we're supplying our cities. But let's say we need to do some operation with our coal plant. Go ahead and stop turning. You can see that we're still supplying the cities. So this grid up here is supplied by multiple different power sources. Okay, very good. Okay, and that kind of gives you the idea of how the utilities work. They keep different plants online to supply whatever needs are there. Okay, I need 3 different volunteers this time. Let's go ahead and try that.
Aww. He just got pumped.
All right. Another concept that's really important is base. 3 more volunteers, 2 more. Okay. And for safety's sake, I'm going to make you stop turning at some point because there's not a lot of current in here, but there's probably enough to give me a little shock.
Let's see.
I'm going to get this
How we need to see how much, right?
Hold these 2 wires.
Yeah, hold these 2 wires. There we go. Okay. Now, when do you think we use the most electricity during the day? At night? At midnight? Noon? In the morning? When do you think we use it? Probably at noon. It's different for different areas, right? Different regions of the country, depending on your climate conditions. And the way we've got this set up now, these first 2 lights are what we're going to call base load. And that's the load that we never go below. It's pretty much what's supplied all the time. And utilities make plants that operate to supply that base load. They operate all the time. They operate very efficiently. They rarely come offline. When they do come offline, they come offline in a planned manner so you can supply that base load. These next 2 lights we're going to call intermediate load. And that's your normal daytime load that you need. There are some plants that the operators come in the morning, they start it up before you're getting up and making your coffee and turning on your television and all those things. They operate the plant through the day, shut down at night, come in the next day. That's kind of your intermediate plant. And then you have what are called peak plants, peak load plants, or peaker plants. And the peak load plants are only needed when there's a lot of energy need. They're not operated all that often. They're very expensive to operate because of that. And so Now these aren't connected to the plants on the other side. We're going to say we got a base load plant, and that's going to be Brian. We have a intermediate plant. Going to mix these up. Okay, Deborah. And Carolyn's going to be our peaker plant. Okay, so let's say it's midnight, we're operating. Go ahead, Brian, start turning yours. Okay, you can see we're supplying our base load. And as we get up in the morning, we start to turn things on, and throughout the day, go ahead and stop a second. We're going to say that people are turning things on. And now go ahead and try and supply that load. It's a little bit harder. He's got to turn harder, so we put on our intermediate load. Go ahead and crank that. Okay. Now we're supplying our intermediate load. Okay, go ahead and stop. And then now it's a really hot day. Everybody's got their air conditioning running. And the utility looks ahead and says, boy, we need to supply power from both our base, our intermediate, and our peaker plant. So go ahead and everybody turn. Okay, so we're supplying all those needs. Go ahead and stop. Now our base load plant, you notice, was operating all the time. On each of those three things was operating all the time. So one of the concepts we need to think about for future energy needs is what kind of sources can provide that base load power that can operate efficiently. If you think about wind and solar, which is a lot of people's answer to our energy needs, by the nature of wind and solar, it's pretty tough to operate at night. Unless you have huge storage capacity, battery capacity to store that energy, which is very expensive, takes a lot of area, probably not going to make it with wind and solar. Go ahead and set those down. All right, thank you very much. I almost skipped right over that. Okay, so now we're going to talk about fossil fuel a little bit, and we talked about this slide. Go ahead, the next one. Oh, did I get it cooked on you? Okay.